All right, let's talk about the last little bit of simple harmonic motion. And that would be looking at some of the equations to find positions and velocities. So, when we're talking about finding your maximum displacement, which we can call x max, well, x max is simply your amplitude, right? Designated as a. Now, if we're looking for v max, your maximum velocity you're going to reach, well, it's 2 pi times the frequency times the amplitude. If we're looking for A max, your maximum acceleration in any given oscillation, well, it's 2 pi f squared times your amplitude. Now, I'm not going to get into the derivation of these guys just yet because it deals with circular motion, which we are not going to cover until next unit. So, um, yeah, we won't get into that just now. Um, Now, the other important equations are finding things as a function of time. So if we want to find our position at any given time, your position at any given time is equal to the amplitude times the cosine of 2 pi times your frequency times that time. Now keep in mind, this isn't x being multiplied by time, this is x as a function of time. So if x was a function of, say, 3 seconds, you would plug in 3 seconds here. Right? So it's giving you its position at any given point in time. Now this is the only one of these equations that's on the equation page, so this is probably the only one you're going to see on the AP exam. I mean, except maybe this one, which is just concept. But yeah. So then if we go even further, if you want to find your velocity as a function of time, it's equal to the amplitude, or sorry, it is equal to negative Vmax times the sine of 2 pi times frequency times time. All right, so you take your Vmax here, make it negative, sine 2 pi, frequency times time. And lastly, your acceleration as a function of time would be your negative Amax times the cosine of 2 pi frequency times time. Now, these look real complicated and kind of scary, but they're really not that bad. Let's actually put these into use. So what I want you to do is take a second and pull up SHM practice number 2 on Google Classroom, and I'll walk you through a couple of these. Now, number 1 says the position of a simple harmonic oscillator is given by the equation x of t is equal to 0.5 times the cosine of pi over 3 times time. Where t is in seconds, we want to know the maximum velocity of this oscillator. Now, before we even look at finding the maximum velocity, let's just kind of think about what this equation is telling us. So look up here at x as a function of time is equal to a cosine 2 pi f times time. Well, if we look down here, this represents our amplitude. Oops. And pi over 3 represents 2 pi f. Right? So if you examine your equation in those regards, it makes your life a lot easier. Right? It makes sense of this stuff. It's not nearly as scary. So if we want to know maximum velocity of this oscillation, well, Vmax is equal to 2 pi f times a. Well, in this case, 2 pi f is pi over 3, and our amplitude is 0.5, right? So Vmax is equal to pi over 3 times 0.5. Alright, so Vmax comes out to 0.524 meters per second. Now, question 2 asks, what is the period of oscillation in question 1? Well, we know that period and frequency have an inverse relationship, right? We also know that 2 pi f is equal to pi over 3. So if we set 2 pi f equal to pi over 3, right, we can solve out for f to get our frequency. So our pi's cancel. Frequency is equal to 1 over 6, which means that your period is 6 seconds. Right, so again, the key is looking at that function that they give you in terms of what is a represented in there and what is your 2 pi f represented by in there. So let's look at one more. In number 3, they tell us that the velocity of a simple harmonic oscillator is given by v of t, so velocity is a function of time, is equal to negative 12 sine of 6t. And we want to know what the amplitude is. Well, first off, we know that this negative 12, right, is your negative Vmax, right? So if we're looking at this, we know that Vmax is 12. Now we also know that 2 pi f is equal to 6. So if we're looking for the amplitude, we know that Vmax is equal to 2 pi f times your amplitude. So 12 is equal to 6 times your amplitude, so your amplitude is 2. So again, just think when you're looking at these equations what each little portion tells you. Now, one thing of advice, like in number 4, you're going to see angular frequency of 2.6 radians per second. Angular frequency is the same as 2 pi f. But again, I don't want to use the term angular frequency just yet because we haven't gone over that in circular motion, but just be aware that it's the same thing. 2 pi f and angular frequency are interchangeable. So that 2.6 would be your angular frequency. So go ahead, give those problems a shot. Also make sure that you check the email that I'm sending out here at about 6 o'clock on Friday, February 12th. That will give you information on accessing the textbook where the test will be. And yeah, have a good weekend. Stay warm.